Dear students, till now you have seen the labs in which you have preprocessed your data. You have implemented a ANN model with different number of layers, which internally performs backpropagation. In the next lab, you have seen in which I am doing manual calculation to achieve the backpropagation to implement the forward pass and backward pass. So these three labs you have seen till now. Now the fourth lab is what I am developing a ANN model with hyperparameter tuning. Now, what do we mean by hyperparameter? The parameters that are giving me hyper output means optimized output, the output with less loss. Okay. Now, for this purpose, import the libraries as usual. Okay. NumPy for your linear algebra, pandas for your data set reading, then matplotlib for your visualization, then split your data using the scalar model. Then here I am developing a multi-layer perceptron. That's why I am importing even the MLP classifier. Then evaluation matrix is accuracy score. So at least you should be able to display what is the accuracy of your MLP with hyperparameter tuning. Okay. And extra points will be added when you are developing a classification report and the confusion matrix. So minimum expectation from you are at least you should be able to display the accuracy. Okay. Now read the same data set which you have used for your lab 2, that is developing an ANN model with backpropagation. Okay, using your read CSV method, read the data set. So these are all the columns available in your data set. Then replace your categorical values using the if else to the numerical values. Okay, now that is what the diagnosis. Then that diagnosis will become my y, that is the dependent, and the rest all values will become my x. Then I am splitting my data set into the 80-20 proportion. Okay, now first I will tell you I will develop a MLP classifier with the number of iterations as 1000. Now I should specify a grid. Now the grid is containing what parameters I am taking. That is hidden layer, activation function, and solver. Then for this parameter, what are the available values? So this will become the grid of 3 by 3 because the rows are 3 for my 3 parameters and the possible values are again 3 which are representing my columns. Okay. Now what the grid search will internally do on these parameters? It will take the first value of your hidden layer. Then that value will be combined with the first value of your activation function and first value of your solver. Then with these combination, it will apply the forward pass and the backward pass and it will check the accuracy. That accuracy will be stored in a grid. Again, in the next iteration, what I will do with the first value fixed and changing just the value in the second parameter and the same value in the third parameter. Means like this combination I will take and I will find out the accuracy. So like this, every combination in the grid is executed in your number of iterations. Accuracy is obtained. That accuracy is stored in some grid. And out of all these accuracies, what is the maximum accuracy that I will find out? And for this accuracy, what are the parameters I have obtained? Those are called as the hyperparameters. Okay. Now we can even display those hyperparameters. That is called as the best parameters. Here you can see that activation function as a logistic, then the hidden layers are 100 and solver is add-on. Means out of these parameters, the first value of your hidden layer, the first value of your activation function, but the third value of your solver is considered as the best parameter, that is the hyperparameter. So with these parameters, again I will develop my MLP classifier with the activation function, solver and hidden layer. And I will find out what is my accuracy after the training and the prediction. So here you can see that the accuracy obtained is 97.37%. So this is what the improvement because of the hyperparameter. The accuracy which was in 90 with the simple backpropagation is improved to 97%. Okay. So I'm expecting from you in exam, at least you should be able to find out accuracy. Okay. So this is what called as a hyperparameter tuning. And if you want to print, even you can print the classification report. First import that report, then define the number of the classes. And for your target, how many classes are there? With those all classes, just output the y test and y predicted values. So your classification report will give you what is the precision recall and advance score and how many tuples are supported by your class 0 and class 1. Okay. And in the same way, you can print the confusion matrix, which is giving you true positive, false positive, true negative, and false negative. Okay, with blue color. So this is a lab which is running your ANN model, means which is developing a multi-layer perceptron model with hyperparameters. Okay, so this is lab 4. Thank you.